Welcome to the session on differentiation, differentiating functions with two or more terms. The objectives for this session are to explore examples of differentiating functions with two or more terms. Recall that for all real values of n and for a constant a, if y equals ax to the power n, then dy dx equals an times x to the power n minus 1. A function with more than one term can be differentiated by differentiating terms one at a time. If y equals ax squared plus bx plus c, where a, b and c are real, then dy dx equals 2ax plus b. How do we differentiate multiple terms? If you can rearrange each term of a function so that it is expressed as ax to the power n, then you can differentiate the function one term at a time. In other words, if y equals f of x plus or minus g of x, then dy dx equals f dash of x plus or minus g dash of x, where f dash of x and g dash of x are the differentiated expressions of f of x and g of x respectively. Here's a summary of the key points. Let's now take a look at an example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 1a first. We are required to differentiate y equals 2x cubed plus 9x. We're going to do this term by term. If y equals 2x cubed plus 9x, then dy dx equals 2 times 3 times x to the 3 minus 1 plus 9. How did we obtain this? We've simply plugged in the values for a and n for this particular term into our formula. So we obtained for 2x cubed, a equals 2 and n equals 3. And we plug that into dy dx equals an times x to the n minus 1. Similarly for 9x, here we have that a equals 9 and n equals 1. And we've plugged that in to find dy dx for 9x. And then tidying up gives us dy dx equals 6x squared plus 9. Now let's solve example 1b. We are required to differentiate the expression shown on your screen. So if y equals x to the 4 plus x cubed minus 2x to the power a half, then we have dy dx equals the expression that you can see now. So let's break this down term by term. So for the term x to the power 4, we have that a equals 1 and n equals 4. And this gives us the resulting dy dx for this term. For the term x cubed, we have a equals 1 and n equals 3. And hence dy dx equals 3 times x to the 3 minus 1. And finally for the term minus 2x to the power a half, a is equal to minus 2 and n is equal to a half. So we have this slightly complicated expression highlighted in red for dy dx for this term. We can therefore tidy up to obtain dy dx equals 4x cubed plus 3x squared minus x to the power minus a half. Now let's solve example 1c. We are required to differentiate the expression on your screen. Now if y equals 4x to the power a third minus 3x cubed, we have this expression for dy dx. Again, let's break this down term by term. So for the first term, a equals 4 and n equals a third. And for the second term, we have a equals minus 3 and n equals 3 to give this expression for dy dx. And so tidying up gives us that dy dx is equal to 4 thirds x to the power minus 2 thirds minus 9x squared. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve example 2a first. We are required to differentiate this expression for y. Now if y equals 2 over 5 times the cube root of x, then clearly we need to rearrange or re-express this in a form that we can work with and then differentiate. So let's rewrite this in a slightly more convenient form. We can express this as y equals 2 over 5 times x to the third. However, this is still not quite in a format that we can work with to find differentials. So here's where 2 over 5 came from, and here's where x to the 1/3 came from. So this is 2/5 times x to the power minus 1/3. Now this is in a form a constant times x to the power a constant. So we can work with this and we can differentiate. When we differentiate, we plug in a equals 2/5 and n equals minus 1/3 to give us the expression for dy dx as shown on your screen. Here's where the 2/5 came from. This is a. And here's where the n came from. Notice that we've plugged this in to dy dx as shown from the formula. And then tidying up gives us minus 2 over 15 multiplied by x to the minus 1 and a third. And now for example 2b. We are required to differentiate y equals x to the 4 times 2x minus 3. Again, this is not quite in a format that we can work with. So we need to rewrite this so that we can work with it and differentiate. So if y equals x to the 4 times 2x minus 3, then multiplying out gives us that y equals 2x to the power 5 minus 3x to the power 4. Here we have 2x to the power 5, and here we have minus 3x to the power 4. Now we can differentiate term by term. So for the term 2x to the power 5, we have a equals 2 and n equals 5. And again, simply plugging into the formula for dy dx gives us the expression shown. And for the second term, minus 3x to the power 4, here we have a equals minus 3 and n equals 4, giving us the expression for dy dx. And so if we tidy up, we obtain 10x to the power 4 minus 12x cubed. Now let's solve example 2c. We are required to differentiate the expression shown on your screen. Again, we need to put this in a format that we can work with. So if y equals 2x minus 1 over x to the power 4, then this can be rewritten as 2x over x to the 4 minus 1 over x to the 4, giving us 2 over x cubed minus 1 over x to the 4. And this can be rewritten as 2x to the minus 3 minus x to the minus 4. So here's our expression for y, which we can now work with in order to differentiate. So differentiating term by term, if we differentiate 2x to the minus 3 first, then we obtain the expression shown by plugging in a equals 2 and n equals minus 3. And for the second term, minus x to the minus 4, we plug in a equals minus 1 and n equals minus 4, giving us this expression for dy dx. This simplifies to the form dy dx equals minus 6x to the minus 4 plus 4x to the minus 5. This brings us to the end of this session. If you have understood its contents, you should be able to explore examples of differentiating functions with 2 or more terms. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.